Hey everybody, nice to see you again here. So we've been doing the tutorial, right? Well, today we're gonna talk about Postgres and how we can use to monitor and to troubleshoot Postgres. So we've been presenting by my colleague Agustin. So as you know, I'm Charlie Batista. So I'm the Postgres tech lead at Percona, and Agustin can introduce himself.
Hi all. I work at the support team. I'm a senior support engineer, and yeah, I'm working mainly with Postgres and MySQL. And one of my main focuses is working with PMM, being close to the dev team and making sure that our customers and our users have what they need regarding monitoring.
Cool, thanks, Gully. By the way, you can also call him Gully. Yeah. So if you see I'm calling him Gully, it's Agustin. Okay, what are you gonna talk today? Our agenda today, we're gonna start presenting what is PMM, right? What is the Percona monitoring tool? We'll see about the PMM's interface, how we can navigate, how we can go through the PMM interface. We're gonna see some metrics on how we can use those metrics to find out problems and to see if our database is healthy or unhealthy. We're gonna walk through them to the query metrics, the OS metrics, and how we can analyze some of those metrics and how we can customize. So one of the most exciting thing about PMM and one of the things that I like the most on PMM is its customization. So it's easy and we can do a lot of customization, and this is one of the things that we're gonna walk through. You see the questions here. Actually, this is to remind you that you can ask questions at any point. You don't need to wait for by the end of the presentation. And sometimes we don't have time in the end of the presentation. So if you have questions, please just raise your hand and ask at any point. Don't be shy. You can interrupt. The lady said it's being recorded, but like we can always edit, and we can say that something is deep fake. So we didn't say if you want to say something. Right, so don't be shy and ask questions at any time. Okay, we're gonna start with the PMM interface, and Agustin is the guy that knows how this works.
Okay, so just to be sure, how of you are already familiar with PMM? Okay, great. So I'll do it a bit faster. Again, if you have questions at any time, just let us know. So the first thing in being able to efficiently use PMM or successfully use it for Postgres is to know what we get from it, right? So first we need to know how it works in terms of the architecture and how to install it, configure it, and then what dashboards and metrics and graphs it provides. So PMM is actually a conjunction of different tools, all into the most used is into a Docker container, but we also have OVA and an AML image that you can use, and it's using all of those tools and actually much more in the background, like for instance Nginx that is not listed there, but mainly what we will focus on is on Grafana, Victoria Metrics, and then Victoria Metrics has the actual metrics, and then ClickHouse has the query information, right? So all of the data regarding the query analytics is going to be in ClickHouse. Then PostgreSQL is used for configuration mainly. So what do we get? We not only have PostgreSQL support, we also have MySQL and all of its variants and MongoDB. So you actually get much more from PMM than just PostgreSQL monitoring, right? As Charlie also said, it's extensible and customizable. So we even can monitor any other databases as long as we can connect to them. So very briefly, the architecture is your regular server client, in which you will have in the server component, you will have all these tools that we mentioned, like ClickHouse, Victoria Metrics, Postgres, and the PMM server will also count with an internal client that we can use to monitor like RDS instances or in serverless mode, let's say. So the other component is, of course, the PMM client, in which we use PMM agent to run all of the exporters, and the PMM admin as the command line interface for the PMM agent and the underlying exporters, right? Why did we change Prometheus for Victera Metrics? Because Victera Metrics allows for a push mode, right? So before, the PMM server had to have the ability to open a connection to the PMM client, right? And this, in some cases, it was not always possible. So with what we are having with the push model is the ability that only the client needs to be able to open a connection to PMM server, which was already a requirement either way, and then we can push metrics from VM agent to the server. In the future, we can also have buffering abilities so that we don't lose any metrics in case of a network disconnection between the two of them. Okay. So why is monitoring needed? This is just a slide that you can read afterwards, but it should be pretty self-explanatory. And let's go now to the interface. So in PMM, we have 3 levels of information or the depth of the information that we have. Are going to be our atomic data. Then we have graphs, which are mostly groups of metrics that are ordered in some cohesive way so that the graph tells us a story in some way. And then the dashboards are groups of graphs that tell a bigger story. For instance, PostgreSQL summary or the OS dashboard that has, we are going to check now in a bit, but it has information on all the subsystems. So we connect to PMM, we are going to be greeted by the home dashboard that when we scroll down, we have a bird's eye view of all the clients that are being monitored by PMM, right? So this is some very basic information in which you have OS related data and then database related data, right? So you can even click on each of these and you would be taken to the appropriate dashboard that has those that information. We have to navigate. It's actually very easy. We have the extensible menu here that will take us to all of the different databases that are supported. And when we hover over PostgreSQL, we're going to have a list of all the dashboards available for PostgreSQL in particular. So after we go, let's say we clicked on the PostgreSQL instance summary, we are going to go to the dashboard. Again, is a group of graphs that can describe something about the dashboard in question. In this case, it's going to be the instance summary, in which we are going to have some high-level information at the beginning, and then we are going to scroll down into the different subsections and graphs available. So moving forward, we are going to talk about query analytics and the different dashboards that we can use to monitor and optimize Postgres.
Thanks, Guli. We as a DBA, not most, but we usually spend a lot of time analyzing queries, right? So our customers, they want the database to run faster. Actually, they always want the database to run faster. It doesn't matter how fast it is, it's never fast enough. So then a lot of time we spend analyzing queries, right? So, and usually what we do is we go for the logs, and well, go for the logs is fine, but it's usually quite boring, right? And it's hard to find information. And one of the dashboards that PMM has is about the query analytics. So on the query analytics, we collect queries that have been running on the database, and we aggregate them here, and we show some information about those queries in a specific. So we can see the query, we can see how much of the load that queries represent. We can see some counters here and some information, and we can go even deeper on queries. But to be able to collect that information, PMM needs an extension on Postgres. So we can either use the pgstat statement, or the PGStat monitor that's been developed by Percona. So if you go back here, back. Those information here, they've been collected. We can, like PGStat statement, they can collect all of those informations. If we have the ability to use PGStat monitor, if we can install the PGStat monitor, then we can collect a bit more information that we do not have on PGStat statement. For example, one that I like here is this, how is the name of this graph? Histogram. So, and how I can use this histogram? What does it mean? Anybody? Nope. What is a histogram used for? Because like I'm saying it's fancy, it's nice, but like, can you elaborate a bit more? Exactly. Standard deviation is a very important information. Why it's important to use standard deviation instead of the average? Why is the difference? Why is average sometimes not enough? You need to eliminate outliers. Sometimes you have one query. Sometimes you don't need to eliminate. Sometimes you need to find them. Because if you, yeah, if you average, so you have a plan information, you put everybody on the same bucket, right? And you can have one specific that take one, and you have 100 queries that take milliseconds. If you average them, then you don't have the right information. If you have a standard deviation, you're gonna see those plots, those points, they're way far from the median. And those are the ones that interest us, right? So sometimes we wanted to work on that query that takes 1 minute. So if we optimize that one query that takes 1 minute, we probably get 80% of the problem, right? And those are when those information that they start to be critical, right? The things when we start using tools like, oops, when you start using tools like PMM, we see many graphs that we're going to see here. We see they're fancy, but we need to have the ability of the interpretation. We need to transform data in information, right? We do collect plenty of data. It collects a lot of data on those databases with our metrics and everything on them, but we need to start understanding how we can do some useful interpretation for them, right? Uh, we'll see here a live demo. Thing is, we never learn because usually demos they never work. Right? But well, we hope. We have an instance. It's actually is running on a virtual. Uh, yeah, we have a colleague that he wrote the name is NDBeaver. You can spin up an instance of Postgres or MySQL or MongoDB, and it works for Kubernetes. It works for Docker. Feel like on GitHub. I recommend you if you want to go there. It's really like 2, 3 commands. You have, for example, a cluster of primary into replicas running. Of course, it's not for production, but for development teams and dev, it's amazing. NDBeaver.
If you're interested, the next we have is on deploying PostgreSQL. Is going to be about that tool. So it's
Yeah.
NDBeaver as in version.
Yeah.
NDBeaver, and it's Nikolai.
Nikolai Halainen, the alt.
Yeah, if not after the talk, I will just give you the link.
Yeah. So this instance is running on NDBeaver. We just started today. So, but we already have some data, we have some metrics. Can you go to back to the main Gully? The Postgres dashboard before we start this one. I want to walk through with a couple dashboards. So actually, here I'm not following that sequence for the spreadsheets. So when we go for the database, like we're going to troubleshoot here. So the first things that we need to do is to select on the left. Can you show them how we get to on the left to the Postgres? Yeah. So you go here, we get to Postgres, we go for the summary, and then you need to select the instance here that we want to see the information, because, well, I might have 100 instances here on my data center. I want to see one. To see, okay, what time range that I want to troubleshoot, right? I might have a problem in the last 5 minutes, but only looking at the last 5 minutes may not show me the whole picture. I may need 1 day ago or 1 week ago, and maybe going 1 week, I can see a pattern here. And I might see that something happens every 12 hours or every 5 hours. And if I go on, I may see that I have a backup. Or I may see that I have some spikes or network spikes, right? So a very important thing when we're going to do troubleshooting is finding patterns. Usually when we have a problem, they do not happen isolated. They have something that causes the problem. So if you have a problem in the last 5, go back a few minutes, go back 1 hour. See if it's been repeated on the last something that's been repeated. Or maybe not. Maybe I just had a spike. I have my t-shirt web store, and now I have this fancy t-shirt to buy them. Well, that's fine. That's a problem that I would like to have on my web store, right? But we need to identify them. So we need to go to the root cause. And can you go down here to show a bit more? Okay. A bit more. I want to see the checkpoints a bit more. Okay. So here, for example, I have those spikes, and then I have nothing, like pretty much flat here that happened. And well, this is the checkpoints that is happening on my data. So can you enlarge those here? I want to check only frame. Look, it's pretty nice, right? Like we have those every few minutes. We have something happen here. They're spiking and come down, spiking and come down. So I know that something is happening on my database of 3 minutes. So those spikes means that from this time average here, whichever it is, I'm having a checkpoint. So my database is flushing. How much data is my database flushing, Golito?
Let's go to the customer.
Okay. So remember that I said that PMM is very customizable. So Agustin just built a dashboard for our presentation today. It's not by default PMM. He built it, right? So, and on his dashboard, he knows how to do it. We have checkpoints here. So, and we have how much WAL files are being written to the disk. And I can tell, well, I'm overloading my disk with checkpoints with data. So I might have a configuration issue, or my configuration is not well adjusted for my work. Because, well, if I check this information here, that is the check. I probably have 5 minutes of this, right? I have 5 minutes of checkpoint timeout. I don't want to time out before 5 minutes. But we saw on the other graph where checking point around 3 minutes. So my configuration is not enough. I need to adjust, for this example, my configuration so I can checkpoint X minutes. Or I can also help the data with giving more memory for my background writer, so it can smooth my checkpoints, so when it's going to write in between, and when I have a point, it's not this spike, it's thinner, right? So we can see those how many problems we see in 2 graphs. 2 graphs only, right? So, and if we go back, can you go to the OS now, Golito?
OS.
Yeah. Sometimes the problem is the database, but sometimes it's reflected on the operational system, right? And people are usually, when they go to troubleshoot on the operational system, they're really scared about CPU, I/O, and those things. We should. And the thing is, if I look at my CPU, and well, I see here, yeah. No, can I just did the match. If I see here, I have a load average that is of 27. What does that mean? What is does this load average of 27 does that mean? Is it good? Is it bad? Can we tell anything if it's good or bad? Load average is just plain unit. That is metrics. It's just 27. Yeah, it's this like there is no unity. It's like this per second or thing. It's just 27. I don't know. That's what is normal. That's a good question. So average, average when you go to the depends on the OS we're working for. If we're working on Linux, pick away average because it is the metrics that reflects how busy your CPUs are in average, right? So and on Linux to calculate the business of the CPU, it takes in account number of processes being running. It takes account the I/O that it does. So in general, it's like a very easy way to explain. If a CPU, if I have 10 CPU and all those 10 CPUs are busy now doing work and doing I/O, I range of they're busy healthy. If I have 10 CPUs and I have a load average of 20, it means that every CPU has to work twice. So then it starts. If I have 10 CPUs and load average of 50, now I have a problem because my system is overloaded. I have my CPUs, they need to load between threads, and also the I/O can kick in. So then my system starts being pretty bad. See, I have here 48 vCPUs, and my load average is 26. Like my box is doing nothing. I'm not even using all the CPUs that I have. And what is misleading sometimes is we see when we look at the CPU activity, we sometimes see the 100%. CPU at 100% is a problem. Maybe not. If I have 48 CPUs and I have 4 or 5 CPUs at 100%, it means that one process or one application is doing a lot of work. Everything else is going fine. So when that job, then that will drop. And average of all the work those CPUs are doing at the same time, right? So this is one of. As we can see, we can go here for hours, going and checking. Really want to tell you today is it's not enough to have a really good tool if we don't know how to. And if I do not know how to live, it like unless I'm working with some things, or if I work selling Ferraris, so it doesn't make a good point for me. That's true. That's true. That's why we're here, Percona, right? Help you interpreting those things so you can hire Percona support. Anyway, it was not in the script. Okay, can you go back to the analytics a little, please? So back to the query analytics here. Can you just click one? Pick one. Yeah. So we have few informations here. Here we are using the start statement. Remember that I said the PG start statement doesn't give all information, so give us enough information a lot of troubleshooting. The thing is, most of the clouds, you're going to find pgstat statement. If you have your database on cloud, RDS, the cloud, it's available of most of them pgstat statement. The data that you're going to get from them, right? So we have information about the queries. We have some metrics that we have from the queries here. We have, for example, the information about the, can you, please? So the description of the tables, right? And one thing that I like, is when using the pgstat monitor, we also have an examples and plan. Can you go to the, no, here is empty. Yeah. All right. So, yeah, if we go, one more.
No, we don't have. You want to see the extended?
Okay, yeah. So the pgstat monitor can also give us the explain of the query. And this is a very important piece of information, the explain of the query. And I'm going to give you an example that I think I talked about this as an example yesterday. I'm creating some challenge every week and I'm posting on my LinkedIn because I'm pro bono tutorial on the internet, so training Chris. And to make people busy, I'm posting some challenge. One challenge that I posted 3 or 4 weeks ago, I created 2 tables, very simple tables. Can you open the GitHub? It's better showing github.altino. Can you go the challenge one? So I have those 2 tables. See, they're very simple tables. I have this table method, and then I have this table meta object. The table meta has a self relationship, the relationship between the ID and the parent. It's like when you go to the supermarket, we have the department, sub-department, and product, so you can have this infinite relationship, right? And we have the objects here. Challenge was to create this report. Can you see here? We have the ID, and then we have the whole hierarchy, the name on the hierarchy, the name of the method that we have here, and the total, the number of items we have inside of each one. This is a nice report, right? And you can use one query to build this report. How can you build that in one query? I use in here a very simple installation of Postgres. Just did a yum install, and it's the free tier Amazon, so I have there, and I have 10 million rows here on the table. Challenge was do this and make your query run in less than 2 seconds without creating indexes. If you see, the only indexes that we have here are the primary keys. No indexes, run this report in less than 2 seconds. I got few really nice answers. By the way, my query was running in less than 700 milliseconds. The full answer was 7. I got some answers. The first one, it was run in 1600 milliseconds. Well, it's less than 2 seconds. So he got the objective. And then I came back. Can you make it run in less than 1 second? That's double of the objective, right? So, and then he came to me with a nice query and an index. For now, we are cheating. Index is not allowed. I need it without index. It runs in 900 something seconds. I asked it, can you make your run faster than mine? Mine is running less than 700. He came back with a query that was running in 120 milliseconds. Without index, changing anything here, without changing anything on the configuration. Only things we did was you explain that was working. His improvement was 10 times optimization on the query without changing anything. If you think about that, how much money you need to put on your stack to make it your database 10 times faster. And this is optimization. Optimization is not going there to the database and tuning parameters. Of course, yeah, we need. But to do tuning parameters, we need it on tools that delegates you. But this level optimization, we can go understanding how the underlying tool works. And out of curiosity, can you go back to, go up? No, no, go up, go up. I want to open the, yeah, analysis. So I started doing the analysis to explain what happened. So let's explain the problem, go down. And here I explain how I created the query, how I started doing those things, and then explain that we needed to use a CT and all this kind of stuff. And then the next one, I'm going to show how we use that and how can we use PMM to get that information and to get level of optimization on the database. You raise your hand? No, I was running on my database. Everything was running on my instance, right? But yeah, that would be nice, right? So remove half of the roles, then yeah, we got to optimize it. How we can get to the change. Can you go down, Guli, to see my select? Last one, yeah, this is, so see my select here, I use one CT. Here, it does the whole, the heart of the job, right? So this is a recursive. It goes for the huge table and goes recursive. His select, he did two CTs. He used one CT to go for the table that has 10 million rows to do the aggregation, and then he did the join. We have his answer. No, no, up, it's another page. Go down, go back. Yeah, no, yeah, go back. It's even more than mine. You know, I said a really bad word because, well, fitted me miserably, right? So it was a beautiful piece of select. And this CT here not only does the trick of the aggregation, but also allows the database to query in parallel. We have parallelization here on this CT. So now we have aggregation and running in parallel. It's because I had only 2 parallel threads enabled that was this fast. If I had more, it probably would be twice as fast. It was ingenious, really amazing. And say we didn't change absolutely nothing on our database. We didn't need to put more CPU, more memory. We didn't need to change the parameters. Absolutely nothing. We didn't need an window to create an index because it is what it is. Just the way that the table is built and how it's being optimized. Let me go back to. No, yes. No. This is, we use the PMM to and PD stat monitor to do the explains. The thing to just a second here. I think I have the explains there. Oh, no. His user configuration on the keyboard that I'm unable to. It's not my thing. Can you go? I want to go back to the challenge. I don't think I have now. Yeah. You can you explain this here? Yeah. So I have the explains here, and this is how we did the trick. So can you go down? No, not so much down. Here. So this is the important part. So when it goes to the huge table. So it has a hash aggregate, it does a right thing, and we'll see eventually here that it goes for millions of, here, we go for millions of rows here, and then it do many things, even doing an index scan. It's ineffective. If you go down, without, yeah, more down, like, yeah, you want to see this one. a bit more. So we're gonna see here that we have workers and we have all this aggregation here that is done by the other CTE. And it does in parallel. All those things here, all those partial plans is being done in parallel. And this is what does the trick and make that thing so fast. And the thing is, I/O is expensive, but when you can do a lot of I/O in parallel, you can just split the bill. And each processor or pays less on its own bill and make things a lot faster. Please. Postgres is natively able, but there are some restrictions. Sometimes you need to help Postgres with the parallelization, right? That I was writing my query was not enabled because I was joining them. Join, it needs to go sequentially. In his way, instead of joining them, he did all the aggregation, all the hard work, and with the result of the hard work, he joined. Then it allowed the Postgres to parallelize this information. Because the parallelization, the result needs to be atomic. It cannot change the end result. Uh, whoops. Okay. And well, yeah, we went over this and the customization.
Tomorrow we are going to have a more in-depth talk about this, but we would also like to briefly mention, in case you know, the amount of stuff we can do to enhance what PMM already is offering. So there are basically two ways of doing it. One is with the custom queries, and the other one is called text file collector. So the nice thing about the custom query is that it's very simple to use, and the client will use the already existing connection configuration to the database to run that query and get the result set and then send back to PMM server. The text file collector will not know how to connect to Postgres, but it's more extensible in the sense that it just reads the text file, and whatever metrics appear there, it will collect them, right? We are going to see how that fits. So in PMM, we have 3 levels of resolution, which are high, medium, and low. High being by default 5 seconds, can go down to 1 second. And then we have, I think it's 10 or 15 seconds medium and something like 1 minute low. These can all be tuned, but the both custom queries and text file collector support all of these resolution levels. Find the custom queries, which are the really easy ones to use, right? So in this case, we were extending what PMM offered in terms of replication information for, in the form of lag, and we already knew that this query could give us which hosts were the secondaries and the amount of lag in megabytes. So in here it says seconds, but it's a typo. So in here we will get the query field. This is a YAML, or your regular YAML file, right? So this will query, which is the query that will be run every 1 second, 10 seconds, or 30 seconds. And then we have the in this case, Victor Metric and PMM server, how they are going to be used, right? So application name is going to be a label, which is basically a string, client address also, and state also. And then we have, for numeric values, we have 2 kinds, so gauge and counter, right? And then PMM, and it will know that we have to result set. In this case, PG replication, application name, PG replication, client address, etc. Right? So PG replication we can think of as the namespace of the. Additionally, PMM client will automatically add labels to these metrics, which is what we use across PMM to be able to then filter down. Remember when we did service name and we selected our instance particular that we wanted to check, PMM will do that automatically for us. So the only thing we need to do is just tell which query we want to run, and then PMM will be able to collect these metrics, and we then will be able to very easily create a graph like this in which we can get for the service name, which is in this case it was the primary Postgres. It will get that the replica with this IP address is having this much replication in megabytes, right? So as we can see here, we need to know a bit of PromQL, but it really is very basic, and with a very few you can do a lot, right? Knowing just with the irate, I would say that you can get a lot of created, right? So remember we said this was a gauge, so this will actually measure in the rate in bytes, right? We could have used counter, which is just like it just counts, right? It's not we would not be using the rate. Those are just like counting events. So with these two small customizations, we can have, and in this case we only had one replica, right? But if we had more, all of them would be listed here. So it's very, very easy to really extend even more power to PMM. So if you check the Postgres dashboards and you see that there is any information missing, of course, first I would like you to let us know, because we can create a feature request and improve the tool. You can contribute to it, of course, we accept pull requests. And if not, we can discuss it and figure out if there is a way in which we can do it, right? So this was the first way of customizing, which was the custom queries. The second one is a bit more tricky, and it's harder to use, but it also provides us with a lot more. The text file collector will just, this is an example of a resulting text file that we will create, right? In this case, we are using a bash script, but you can use anything you want that can write to a file, right? So very briefly, what we are doing here is, as the initial state, we are getting the current LSN that has been written to the walls, right? And then we are going to go into we are going to sleep for 10 seconds because medium resolution. And what we are going to do is, okay, give me the current LSN, and I will subtract it with the last LSN that I used, right? So that will give us difference in bytes from the last 10 seconds, right? So what do with that? Simply write a file that has the metric name, which is going to be PostgreSQL wall LSN bytes. And here comes the tricky part. PMM client doesn't know that we are planning on, or basically that we connected to this Postgres instance and that we are planning on having the metric for that instance, right? Because this could have also collected, I don't know, an OS metric that you want, or your own application metric. Let's say you have the latency or whichever other information that you want to gather. PMM doesn't have any information from where these metrics come, right? So in this case, we need to explicit that the service name, so our Postgres instance, is for the primary, right? And then this is going to be translated into what we see below here, that is the PostgreSQL LSN bytes, the metric name, the label is going to be the primary, and this is the value, the current value in bytes that we will have. So every 10 seconds, PMM will read this file, which is going to be always the same file, right? Because we are writing, we are always writing, we are not appending, we are overwriting it, right? So it will go open that file, sequentially go through it, and get metric labels and the value. That will be sent to PMM server, okay? Back to PMM server, what we can do in this case is, and why did we do that with the text file collector? Because we needed some intelligence in the script, because we needed to have the value from before, right? The queries are stateless, so the query collector will just run that query. Think of it as connecting, running that query, and disconnecting, right? And you don't have much more power than that. Okay. So what did we do here? This is basically the graph that Charlie showed before, right? We can get for the checkpoint timeout period, we can get all of these bytes, sum them up, and say, okay, in these 5 or whatever minutes, yeah, you wrote, which is this, like 7 gigs, right? And your Maxwell size used to be, I don't know, something very low. Then it's gig, and then when you increase it to 12 gigs, you start seeing less checkpointing activity, which of course is what you want, right? You want to have checkpoints, but you want to control when they will happen, right? This will be less taxing on your I/O subsystem, right? So before, as you can see, we had a lot of checkpointing going crazy all of the time, and the wall size was really low for the amount of writes that we had. So this is another thing that we helped build, and it's not yet on upstream, but we are discussing how to implement this in a more way, so that we can include it in our metrics, right? So there is also the ability of customizing via external exporters, but if you're really interested in that, we're going to have a talk, I guess it's tomorrow, on customizing PMM.
Last thing that we want to show here are the alerts and advisors. So we can have advisors and alerts on PMM. The advisors, as we see here, are a piece of software that they run from time to time, like for example, every day at midnight, to do a check on your database and check if something is wrong. For example, if your database, if you have a user without password, or if you have the port open to the world, or those security checks. So they can be created and configurable. So this one, it comes by default without anything, and it can be created more. And for those that were on the presentation today, on the keynotes, if we do a subscription for the platform, and there is the subscription, you also get more advisors that are being pre-created, and we have plans to always adding more and more and more advisors here. So this is to have a health checks on the database. Those are not alerts. Alerting are the other things. We can also create them. So PMM has integrated alerting. So we can create alerts here, and PMM, we can use integration with SMS and emails and Slack and those things to send message when something happens. For example, if we have a MySQL down or a Postgres down, if we have a database overloaded. So those are alerts. Alerts and advisors, they might see similar, but they have different purpose. So the advisors is to give you, as the name say, an advice. So it's really good for you when create a user to give the final, right? Your database won't stop if your user doesn't have password, but it's not nice. An alerting is, okay, look, your database just stopped. That's a problem. Well, a more urgent problem, right? So those are the main difference. We can be used both on PMM. And that's it, right? So that's it. Everybody here. And well, as you know, we are passionate for open source on Postgres. And so not only Postgres, have Postgres, MySQL, MongoDB, and we're always trying to help and improve the community. We are hiring, and if you have questions, ask this guy, answer any question that you have. Thanks.